For the last two parts, we're going to be using the numbers inside the table. Those numbers inside the table represent probabilities. I'm going to find the probability, and I'm going to find the corresponding z that represents that probability, and then I'm going to convert my z to a real world x using z equals x minus the mean over sigma. So let's read the same problem. It's about load times, but and you want to look in the guts of your table, which of these 4 digits numbers are closest to 0.4. And if you look, make this bigger, 1.2, isn't 0.4 closer to that number than it is to that number? If you jump down to the next line, it's 0.4032. So 0.4 is closest to that probability right there. And what is the z that corresponds to that? It's 1.28. So let's go back to our problem and look for 0.475. What's the number closest to point? Oh, there it is exactly. And that corresponds to a z of 1.96. Part D, how much in seconds will elapse before the fastest 10% of the sales pages load? Okay, so we're talking about seconds. We've been talking about seconds even for the first 3 parts. But I want to draw a picture. In this problem, it doesn't say, oh, how long does it take? What's the probability it downloads in less than 2 minutes? It says, I'm trying to find how much time will elapse before the fastest 10% are loaded. Now this 10%, that's 0.10, and that's going to be somewhere underneath our curve. 0.10 would be down here in the left tail, because the numbers on this horizontal axis are getting larger, and I want the fastest video elapsed times, and so that means it will be a smaller number. That's why 0.10 is the probability in the left tail. So I want you to, let's go back to our table, and our table gives us probabilities in between 0 and whatever z I look up. Now, if this is 0.1, this would be 0.4. Do you agree? So you want to go back to your the z corresponding to this is negative 1.28, and that's a z. But I'm trying to figure out how much time. Time is real world, it's an x. So take your formula, z equals x minus the mean over sigma, and your z is negative 1.28, and we're trying to find the x, and the mean is still 7, and the standard deviation is 2. Multiply both sides by 2 to clear your fractions, and that gives you negative 2.56 equals x minus 7. Add 7 to both sides, and you get x equal 4.44 seconds. So how many seconds will elapse before the fastest 10% of the pages load? 4.44 seconds. All right, now let's look at the last one. What are the lower and upper values of x? What are the lower and upper values of x symmetrically distributed around the mean that include 95%? Okay, so what I'm trying to do here, it says symmetrical about the mean. This is the mean, and I want this to be 95%. Between here and here is 95%. Okay, now that's the same thing as 0.95, probability underneath the curve. If you take 0.95 and divide it by 2, you get 0.475 is here and 0.475 is there. So what I want you to do, we're trying to find this z. And of course, this will be the same z, except it'll be negative. Okay? And then we're going to convert that to an x. So let's go back to our table. So this is positive 1.96, and this is negative 1.96. So let's convert both of those to x's. Let's take the positive 1.96. I'll change back. 1.96 equals x minus 7 over 2. That's 3.92 equals x minus 7. Let's add 7 to both sides, and that gives me 10.92. Now let's do negative 1.96. Negative 1.96 equals x minus 7 over 2. That's negative 3.92 equals x minus 7. Add 7 to both sides, and you get 3.08. So this x is 10.92 on the upper end and 3.08 on the lower end. And what that means is 95% of load times are between 3.08 seconds and 10.92 seconds.